The Netherlands is one of the best countries in the world to live in. It has a strong economy, and some of the world's best DJs were born here. There's only one downside. It rains 145 days a year.
At Google, we solved this problem by repurposing Holland's old windmills, using them not to capture wind, but to generate it. To pull this off, we needed to build a better understanding of the weather. We used Google Cloud Platform to predict how clouds will behave. We then connected all 1,170 windmills in Holland to prevent bad weather from happening.
Let's take it for a spin.
Machine learning enables all the mills to collaborate.
Of course, we need some rain now and then. With Google Wind, we can also decide when and where it rains. So Google Wind is able to keep clear skies any season.
Mensen, zon, zon en nog eens zon. Net als de rest van het jaar.
I'm proud to announce that from April 1st, we're able to guarantee clear skies for everyone.
Woo! All right. Let's have some fun.
Yeah, well, that was a really, really awesome video, man. And my name is Ray. I'm a developer advocate for Google Wind temporarily, and also for cloud. And I love to bring some of our latest and greatest technology to developers all over the world. So if you have any questions, please feel free to reach out on Twitter. And we're very lucky today to have Head of Engineering with us here today.
Hi, I'm Matt Feigal. I work in Amsterdam also, on the Google, leading the Google Wind team. And also, I occasionally work on the Google Cloud products when they let me.
Yeah, a lot, very often, or 20%.
20% project or so.
Yeah, we wish we have you more. So Matt, what are you going to show today?
We decided we didn't want to talk about Kubernetes today. Instead, we're actually going to talk about Google Wind for 45 minutes. Because as you just saw, Google Wind is this great product, very relevant to the Netherlands to keep sunny skies for everyone. And we really, might be asking yourself, how does this actually work? Like, how do they make this crazy thing happen? Well, we actually wrote a technical blog post and GitHub repo. You can take a look at the machine learning models and how it all works. Really go there, it exists. But in the end, it's very similar to a control feedback response you might have from any of your device systems, right? In your data centers or your IoT systems. We're gathering radar data from the...
I got it.
We start by gathering huge amounts of radar data from the European radar network. We're using Spark for that because the communities have built a lot of logic to process that. We want to reuse all of that good work they've done. We're running it on Cloud Dataproc, which is just a fully managed version of Spark running on Google. We're also taking in real-time sensor data from those windmills, merging it all in Apache Beam, using that to merge out. Do you guys know what Apache Beam is? It uses Java, so hopefully you do. Who's played with Beam before? Aaron? A few people. Okay. It's essentially it handles batch or streaming data really nicely, so it's perfect for this. It's an open source product. Again, we're running a fully managed version on Cloud Dataflow, and then we do two things with that data. We dump some of it into Bigquery. We dump all the data into Bigquery where our analysts and researchers can do historical data over petabytes of weather data. And also, but more relevant to Google Wind, we use TensorFlow, which is this open source machine learning library where it allows our application developers, without having to be machine learning PhDs, to build trained models on the historical data, make predictions, and then use that to drive the behavior that we want back to the windmills. There's something missing, though. We've been running this for about 6 months now. It's not really being as sunny as we need. People aren't happy with it. Something's not, we're not really getting the feedback we expected. And what we realized was we really can't predict. You guys, you developers, might have some great ideas of how to use the wind other than just to keep the skies sunny, right? You guys have your own ideas that we've never even thought of. So today we thought you might even want to you want to have good rain in your garden so you don't have to use your hose all the time. So today we're launching the Google Wind API to the JFrog developers. So that's what we're going to talk about today for the next 40 minutes. is how this works, how the API works. It's all built on top of Kubernetes, and we're hoping to go do something really cool. So you guys, as developers, you're going to get the first access to it. You can tell it if you want it sunny or cloudy or certain wind conditions in your city. And the API will drive Google Wind to the state that you want. Ray, why don't you show off the console that we've built for them?
Yeah, so this is our fancy Google Wind API console. Basically, because API, we gotta write code to call it, so we basically just wrote the front end for the API. The way it works is actually you put your name in there, you put the city that you want to change the weather, and then you put in the desired weather into it, and then you press request. Oh, by the way, we got all of these tuning knobs that you can choose, fine-tune the weather that you want, temperature, humidity, whatever that you want. And when you press request, we'll store it somewhere. We'll have a log of histories of who was it that wanted to have thunderstorm today, right? And we can actually see here. The way it was structured is that all of these things are being passed to the backend via microservices. So we got the front end in the UI. It's a Spring Boot application. We have the weather data API. That's a microservice by itself. And you can query the current weather. And then we also have the Google Wind Control API, which is the thing that we will be using to control all the windmills, right? And of course, we store the data in MySQL and Redis as well. So with all being said, it is a microservices-based application, and we do deploy this into Kubernetes. So without further ado, let's take a look.
Yeah, since this is a really technical audience, let's see what happens behind the scenes on this.
Yeah.
How's it built?
So very quickly, though, to deploy anything into Kubernetes, we have these YAML files. These actually explains how the desired state of the application should look like. Right, so it has what image you want to deploy, how many instances of it do you want, and we have a little visualization tool that we can use to kind of see what's going on. So maybe I can go here, and let me go to static, right? And people are like thinking like, there's not about Kubernetes today? Darn, I'm in the wrong session. But you can see that we deployed everything into my cluster that has 5 nodes, right? And this cluster is running on Google Cloud Platform right now. And you can see very clearly I got the UI running here. I have 2 instances, and I can change how many instances I want through Kubernetes deployment. And you can also see very clearly these lines on who's talking to what. We're talking to Redis, we're talking to the control service, and so on and so forth. And we also have this public IP address that anybody can use today as well. And we can just, you ready
let's
to
show
show?
the UI. Let's
take a look.
see what it looks like when we load it.
Yeah, so I got this open. Cool. That's good stuff, and let's see it. Wait, hold on a sec.
Wait, yeah, load that again.
Dude.
Can you hit refresh? Uh-oh.
I don't know. Internal server error, 500?
500. So that's there's a 404.
404 in the null? It must be a Java application.
No, there's something wrong. Yeah, it's a Java application.
Yeah, but we got all the worst of the error messages mixed in here.
Yeah,
but
that doesn't make any sense.
Do you have a video?
Yeah, let's switch to the video. Yeah, switch to the video.
No, do you have the video?
No, you were going to record the video. You have the backup video, right?
No, I was at the speakers dinner yesterday.
Well, I was coding this thing until midnight last night. I didn't have time.
So
to
you broke it?
No, I didn't break it. It works in staging. And I mean, of course, I deployed it first to staging. I tested it, and then it went to production.
Okay.
And it worked last night when I tested it, so it was ready to go today. Nobody's touched it since then, right?
I haven't.
I haven't.
Yeah.
Okay.
But you do have a staging environment.
Yeah.
All right.
A staging environment.
Let's take a look at staging.
Yeah, so it works in staging.
You sure?
I'm sure.
I mean, come on, seriously. Like, the audio didn't work when we got here. There was no internet. This is a bad day. Let's see here. So luckily in Kubernetes, we actually carve up the cluster into multiple namespaces. Oh, thank goodness the internet is working. And we have a staging environment, a staging namespace. So you deployed the same application into the staging environment. Mm-hmm. So we should see exactly the same application, but
exactly the same
separate.
application.
All right. So let's just take a look here. So I can do for namespace and staging, and I'm going to get my service here, and I should be able to see the staging UI here. So let's go take a look. All right. So this is obviously working. Okay. So let's try that one.
Okay, it works. It works in staging.
All right. Oh, it works.
Okay, good.
Hey, wait a second. That doesn't look like the screenshot that we just showed earlier. Like.
Oh, we might have some code divergence.
All right. Fair enough. But you can see that you can change whatever you want here. I'm going to say Ray. I'm going to say Ede here, right? It was cloudy. It was cloudy outside, right?
Yeah, it was cloudy outside. Let's make it sunny.
Make it sunny, yeah. But this is staging environment, so you're not going to see any changes.
Yeah. So.
Right. Okay.
Yeah, you're right. Yeah, it's
Right.
not actually going to work, right? So if you hit this IP address, it won't.
Yeah. Okay, so we see. Okay, that's pretty
Yeah.
good. You want to try another one?
Yeah, let's make it sunny in Amsterdam, so it's nice when I get home.
All right, so let's make it sunny as well.
Yeah.
All right.
And
So,
again,
oh, by the way, you actually see the current weather condition is cloudy.
right, so that microservice is working too. That's reporting back what
Wait.
the current state is.
No, but what if I do Utrecht? And let me do sunny. And Utrecht is cloudy.
Yeah, see,
Did you
it's
just
working.
hard code this? Did you just
no, it
hard code
works.
every Netherlands city to be cloudy? Is that?
No. There's some cities in the Netherlands that might be sunny. Let's try one outside of the Netherlands. How about
right.
Philadelphia?
Philadelphia is always sunny, right? So Philadelphia, and let's make it cloudy, right?
Yeah.
And oh, you're right.
Okay,
Philadelphia
see,
is sunny.
yeah,
All right,
okay.
all right. I trust you. You didn't hard code this. All right.
So this is
Very
all
good.
working in staging.
So staging is working, but production is not. Well, of course, staging was working.
Right.
Because why would you push something to
I
production?
deploy to staging.
Yeah.
That's the best practices, right? Deploy to staging, test it, deploy it, then send to production.
Yeah. Are you sure they're running the same application?
I'm pretty sure. It was pretty
Yeah?
late. I don't know. We better check.
All right. So in Kubernetes, the surest way to see what is actually running is you can see the instances by using get pods, and you can do a kubectl describe the pod, and then just see what you actually deploy here, right?
Yeah.
So we have the UI, and you can scroll up, you can see all the details, all the configuration details as well, like these are the endpoints we're hitting. If I scroll up a little more, we see image is latest.
See? Deployed latest to staging.
Wow,
Because I mean,
latest?
this naturally happens when I push it. Just deploys latest.
Yeah, you took continuous delivery to the next level. You always push latest, right? But Matt, latest is not always the right version. Your
It's always
latest
the right version when I've written the latest.
on your machine,
Yeah.
but on my machine, my latest could be different from yours.
Oh, you mean there's a team I have to work with that might have different versions.
Yeah. So how do we know which one this actually is? Right? Because we don't know what latest is. One of the things here is never push a tag latest into your environment because you will never know what that is. You should always tag your images. But luckily, we can actually see the child hash. That can tell us for sure.
Okay.
All right. So if I was using some kind of tool like, say, JFrog Artifactory, I can copy and paste this hash into the search, and I can actually see what image this is. But I'm not using that right now. But what we can do is we can just compare this hash. 1F5D7.
Oh, come on, you can remember the whole thing. You're a scientist,
Oh,
right?
shoot. SSH key. We need to remove this this cut. All right,
Cut.
restart. All right. Let's try this again. All right, get pods. I gotta be very careful now of what's actually in my history right now. So I'm gonna do get pod. I'm gonna type everything out from now on. I'm not even gonna do the cheat here. So I'm gonna say describe pod. Oh, did everybody see that? Did somebody take a photo? I hope not. Yeah. Oh, shoot. Cut. All right, so I'm looking at the staging environment, and I should be able to see the hash. Now, of course, I memorized the whole thing, the last 5 digits, 1F5D7. Yeah,
Good.
it's the
Yeah.
same thing.
And I remember the whole thing.
Yeah. You remember the whole thing, yeah. All right. So we're sure that this is running exactly the same app.
So we're writing the same thing in staging and in production, but in production it's not working.
Right.
How can we confirm that it's actually, is there another way? Can we actually look at the instance itself?
Yeah.
What's
So
happening there?
we need to look into the logs, right? That typically once you have these issues and when you have a very bad error message like that one, you don't know what's going on, so you gotta look into the logs,
Not
right?
very educational.
Yeah. So if you are on the old systems, right, you have to SSH into the right box. You have to go find the right login directory, and you gotta see the logs that way. Well, in Kubernetes, you can just use the command line here, and you just say logs, and you give it the name of the instance. These are pods, and you can just press enter. Yeah?
But Ray, there's two of those UI. There's two of those UI machines there.
shoot, you're right.
You only got a 50% chance of getting the right one.
You're absolutely right.
I mean,
Yeah.
you could just try it, right?
Yeah, I can try it. Yeah. But the problem is if if you're in production, if you have that many instances,
Yeah.
then what do you do?
10% chance.
Yeah, 10% chance, right? Yeah, that's a little problematic. But let's see how this works, right? So I can getting just one. Oh, we are very lucky today. So we got one error here. Okay, we can scroll all the way up. Right, I can do this to all of the instances.
Yes. Yeah, you'd have to, but it's still kind of like the old way of hunting through a bunch of different instances to find your logs, right?
Yeah, it's not very useful. But somebody actually told me after one of the sessions about this really neat utility, and it's called Stern. And with Stern, you can actually just give it the name of the deployments. For example, what was it called? Whether
Are you guys, hang on a second. Are you guys hearing this weird?
Yeah.
We've got this.
Who's playing the
scratch?
DJ stuff? Yeah, like, yeah. Yeah, unplug. Which one? Here, I'm gonna turn mine off. Oh, it's me.
It's you.
Yeah.
It's still there?
Yeah, all right, well. Yeah, it's the wind, yeah. It could be, but hopefully somebody in the back will fix it. So I can actually use Stern, and I can just give it the deployment, and what this will do is actually get all of the instances back, and you can actually see all the messages flowing by, right? So I can go back to this thing, and it doesn't matter which instance it lands on, it can always it will always show up, right? So when you're trying to see all the logs, Stern is a pretty awesome utility that you can use.
So that's nice, but I also see a bit of a. Is my mic on now? Did I just turn it off by accident?
No, yours is on.
Mine's on? Okay,
Yeah.
good. That's nice, but here this works really nicely in staging, right? Where we've got a reasonable flow of logs.
Yeah.
But now in production, we're going to have hundreds of thousands of people hitting this all the time. We're going to have so much. It's going to be streaming back so fast. There's no way we're going to be able to actually process this and see this.
Right.
So what we actually need is more of a centralized logging area where we can get all of our logs forwarded into one area where we can ask questions of it, explore it at a bit more our own pace, right?
Right.
So if we're doing this on premise, we probably use a tool like Elasticsearch and Elk Stack, which would gather the SDD, the standard I/O out that we put from Kubernetes, and would forward us all into a system where we can actually then go explore and understand things ourselves, right?
Yeah. Yep.
This is a good way because when you have these distributed systems, you really need a centralized logging area to get everything correlated in one place.
Right.
Now, since we're running this in Kubernetes, we've got pre-installed an agent that is sending these error logs to Stackdriver.
Because we're using this on Google Cloud, right? So we have a centralized agent pre-installed here. So it's going to have very similar functionalities as what you would expect from a centralized logger. But let's go take a look. Where is it? Logging. There you go.
Yeah, logging.
Okay. And
so what we can do, since this is all coming into this to explore this information, there's a lot of information here, right? Our system's generating a lot of logs, so we can actually narrow it down a little bit, right? We might go into our Kubernetes environment, container engine here. We might be running multiple clusters, so we can see all of the clusters, search through them if we're running a whole lot of them. Even narrow it down to our namespace, right? We've got a staging name environment, a CI/CD area. We're going to narrow it down to our production area. But still, we've got a lot of logs, right? Still, we got to explore this to try to find our errors. Spoiler, there it is. Well, we will probably want to narrow it down even further, right? So let's narrow it down just to the user interface service that we need to see. And okay, we've got, it's narrowed down a little bit.
Yeah.
But also then we might just do some text searches. So I'm just going to say, look, I really just want to find everything in that area that has exceptions in it, and that helps us narrow down and find our log errors in the exceptions.
Okay, so I can open this up. Yeah. Okay. Yeah. So I can see the same log messages here.
Yeah.
Oh, that's.
And hopefully that's a lot better than taking log files from a bunch of machines, grepping through them, and stuff like that.
Yeah.
Or do you miss those days?
No, actually, no, I don't. Yeah, I remember the days where I was on call for a while for a hotel company, and every 3 a.m. in the morning, I have to troubleshoot things, right? But having just the current log is pretty nice, right? I remember SSHing to the machines and trying to download the right logs, and then you have to, how do you query it? You use a grep or you write a Perl script. That's what I used to do. But what was really useful for me is to be able to ask questions on the logs, right? So for example, one of the things I really wanted to do was to try to figure out, remember this 3 a.m. in the morning, I needed to figure out, is this actually happening on just one of the instances, or is it happening on all of the instances, right? Because if it's happening on all of the instances, then I know I'm not going to go back to sleep because it's a major outage. But if it's happening on limited instance, maybe it's just bad configuration. I can fix it, right? So there are actually really easy way for us to do this as well, right? Yep. So for example, we need to be able to ask these kind of questions in a centralized logger, right?
So there's some good ways to do that, right? In this interface, you can't really do it, but there's a lot of other options for you to do that in the way you prefer. So we can actually create an export. We've got a running export of this data going in for us. And we can send the logging data into different syncs, right? We can send it to PubSub, which is just a messaging service, which allows us to do near real-time analysis if we actually really want to watch the streaming data for certain events. we can dump everything into cloud storage if we need to keep these logs for long-term storage for some reason, or if we just have other tools that we want to use. My favorite is Bigquery, to dump all of these logs into Bigquery. Bigquery is actually was originally built by Google 10 years ago as a tool for as an analytics tool for exactly this tool, to query petabytes of logs, of internal logs for us, and we exposed it to developers like you about 5 years ago, and we're techies, so we can write SQL, and that allows us to come and explore the data that's being exported. Ray's already got a lot of it dumped out here.
Yeah, so we actually have this export set up already, and I can actually go into the UI here. So I can go into the log, and this is a structured query, so we can query any of these fields. I have a query pre-written already, so these are the type of questions we can ask. So one of my favorite questions to ask is this happening with just one instance or is multiple instances? So I can write a query here that asks exactly that question, right? Basically from my app, I want to count the exceptions, group by the name of the instance I have, count order by the occurrences, and rather than querying just one day, I can also query for all of the days if I want to, right? And I can run this query. Again, doesn't matter how much data that you have in the logs, we will be able to query it, and out comes the result, and let's see what we got. And evidently, right, we have many instances running, and apparently it is pretty equally distributed, but this one has the most issue, D2Z05. What do you do when you find the issue with just one instance, Matt?
Well, obviously, we just reboot that instance, right? We restart our JVM, or let's just get rid of it.
You want to kill it?
Yeah. Well, we're trying to give a demo here. We're trying to demo the console. We've got like 150 people here waiting to see it. We've got to just wipe it out and start over, right?
No, but if you just kill the instance, of course, Kubernetes will restart it for you. But what if this happens again in our next demo in like 2 weeks? Or, what if this production environment happens?
Before then, right? No, okay, you're right. You're convinced. Yeah. Let's troubleshoot it today.
Yeah. So there's actually a really nice little feature that a few people know within Kubernetes, which is the fact that when you are routing these traffic through the load balancers, one of the things that they choose which instances to use is by using labels. So what that means is, I don't want to delete. I'm going to type everything out today. So what I'm going to do is I'm going to say get pods. Yeah, I don't want SSH key on there again. So I can show the label, maybe app and serving, right? And so for each one of these instances, we can actually see these labels. And this is what the load balancer uses to pick and choose which instances to route the traffic to. And because we're routing to the app specifically, and also a serving flag equal to true, what that means is we can simply turn the flag to false, and we can keep the application instance running, and it will be no more traffic serving it.
So we can debug it at our own leisure.
Then we can debug it at our own leisure. We can do whatever we want with it, right? So for example, let me see here. So I'm going to do this one. It's a little loans, right? So I can do weather control UI, right? And let me just blow this up a little bit. I can take, for example, this instance out of service. I can set the serving label to false. And because how my service is set up, as soon as I do this, no more traffic will be going to this instance. If I say get pods again, it's a little hard to see. But you can see that there's one instance that is false, right? But so now we can debug it. However,
there's also a new one.
Yes.
Oops, sorry. A new one created 10 seconds ago.
Yeah.
Kubernetes, of course, created a new one to replace it.
Yep, because we tell Kubernetes we want 10, and it's always going to keep 10 running. So even if we took out of instance, it's going to restart another instance for us. But now we can do interesting things, right? We can safely go into it, go into exec, right? So like Docker, you can go into the container. Rather than figuring out what machine this is running on, with Kubernetes, you can just do kubectl exec, and right here, you are in the shell of that container. You can also, if you're running Java, right, you can dump a thread dump by sending a signal. What was the signal again? Anyone remember? 3? It's not 9? No? You don't want to kill it? All right. So you can do that, and it's going to send a signal to the process, and it's going to do whatever it's going to do. But we can do even more, right? Because sometimes we might want to, for example, see if this instance is as bad as we thought it would be, right? Or maybe there's a GMX console that you want to log into to make a few changes. Well, in Kubernetes, you can also use this little really awesome utility called pull forward. And you can just give it the instance of the pod or the application, and you can say, I want to forward from my local port 9090, I want to forward it to the remote port in this specific container, port 8080. Okay? So for example, right now, this thing doesn't work. right? So I already took out of the service, and it still doesn't work. So maybe there's a bigger issue here. But let's see here. So I'm going to go to my local port 9090.
See if it works.
Okay. So because I think that was the bad instance, and let's see. Huh.
Oh.
Well,
That look. Oh.
what?
And somebody's requesting.
Who is that?
Bjorn. Bjorn does not like sits hard.
Who is that person? Tropical storm.
Oh. He's causing trouble.
Wow. See, that is why we keep record of this, right?
Yeah, exactly.
So okay. So this instance was good.
Yeah. But now I'm confused, right? So that instance wasn't working in production, but actually when we log into that instance and hit it, actually everything's working, right? It's connecting to its microservices. It's connecting to things properly.
Right.
So I mean, we've got to keep troubleshooting, right? So let's think what else we could look at. So we've got a microservices architecture, which means all these complex things are communicating with each other.
Right.
How can we confirm that they're actually talking to each other, that the networks, that they're actually able to reach?
Let me show you my awesome dashboard, right? So let me go back to this dashboard, which is there we go. So so you can clearly see that this is live, right? That you can see the new pods here, and they are clearly talking to each other with the lines.
Yeah, those are very pretty lines, Ray.
Yeah, I mean, look at that. They're all talking to each other, supposedly.
Aren't those lines? I saw you put define all those lines in your YAML file. Are we actually kind of looking at documentation here rather than the real state?
Well, I guess you could be right. So let me show you what he's talking about. So in my deployment here, these lines are actually drawn by my annotation here. So literally, you can put whatever you want, and it's going to draw a line for you. So you're right, Matt. This is not exactly the live
real state of the application.
No.
Everything else in there was real, but I think those lines were drawn by your tool.
I think you're right.
So actually, what we really need is some other set of observability, right? Like to observe what's really happening. How can we look at that?
Right. Yeah. So remember the days where maybe it happened to you, like you were trying to hunt down an issue, and you look at the documentation for like half a day to a day, and then somebody tap on your shoulder and say, "Sorry, buddy, but you're looking at the outdated documentation."
I haven't written the new docs yet. I'm sorry.
So this could be very well the case. So in a microservices deployment, you do want to have some kind of near real-time observability. And there are multiple ways for you to do it. One of the really cool tools is called Weave. I don't know if anyone's seen Weave before, but what this can actually do, I should show this little thing right now. So I can open the pull forward to Weave, and I can get into what this is called Weave Scope. This is pretty cool. And I can actually see the live traffic and the live real connections that's actually established by the different microservices, right? So I can clearly see that UI is talking to Redis. I don't know if UI is talking to the control service here because there's no line, but if it went through, it should actually occur. This is all in real time. But even better, we can actually get more visibility with distributed tracing, right?
Right.
So
right now, what do Java developers use for that? Zipkin?
Yeah, so in a lot of times, if you're building a microservices application, you may want to trace the microservices call. So if we're calling from the UI to service A and service B, you need to see the latency between them. You need to see the code stack is actually going through. Okay. Like Mac caught me, like my dashboard is not in real time, but typically you may want to use like Zipkin for having a real input into how everything's connected. So maybe that's what we should look at.
Okay.
Yeah, so we actually run Zipkin right now. So if I can show you, get pod. Come on, where is it? Did my internet just die? Oh, there we go, get pods. And we have Zipkin right here. And you can, of course, run your own Zipkin, right? And then you can log into the Zipkin console. You can see everything. But this Zipkin is a little special. This is a little proxy that we put in front of, oh, sorry, not that one. That's what we put in. Into Google Cloud as well. So what you can do is you can actually see all the trace data, not directly from the Zipkin console, but you can actually use our console as well. And if I get in here, I can probably see the trace list. Okay. And here I can narrow down to 1 hour. So let's see what happened to this particular call, right? So I got, not that one, staging, and this one's the one that's bad, right? So I can see, for example, if I zoom in, that is a successful call. Somebody wanted to change the weather in Sittard. I don't know what that is. Yeah,
so that means Bjorn is using the production version where we're failing.
Yeah, so somebody actually got this work.
So it's working for you guys, but not for us. So we're still having to try, we're tracking down even more complicated things in production.
Yeah, and I think we saw a 404 error, so we can actually try to find that, right? So, there's tons of 404s. Let me see here. Ah, there we go.
Okay,
so I found this call. It's calling with the weather service, and I can clearly see that, this
there we go.
call actually failed.
So
Yeah,
now we know
404.
which microservice call is failing.
Yeah.
So
Yeah.
we've tracked down through, we've had it running in production,
Yep.
staging, we've tracked down the problems weren't there.
Right.
We finally tracked it down to this call to this microservice
Right.
is failing.
Right.
Okay.
Yeah.
But our error message is still pretty useless on the screen.
Okay.
We didn't find anything useful on the log. So,
Right.
Ray, I mean, I don't like where this is going. I don't think we're going to solve this in time for this demo, right? Because normally what I have to do now
Yeah.
is I have to go pull down the latest version, not the latest, sorry.
Not the latest.
I have to pull down on my machine the version of the code that's running in production.
Right.
I have to add a bunch of logs to it to improve the logs, right?
Right.
So I'm going to add a log statement probably every other line or something.
Right.
And then I have to deploy that back to production, which might
Right.
take a while.
Right.
And then we have to sit there and wait for someone to hit the error again. This doesn't sound like very much fun. I don't think we're going to get this working.
It will take. It will probably, like if you're in a traditional environment, it will probably take like 4 hours to half a day to just deploy a new version. But Matt, what if after all that troubleshooting, you got the new log messages in, and you figure out, oh no, I need more log messages, right?
Then I would have to start over and do it again.
Yeah, yeah, and I think
Which
we can.
is not going to be fun.
And we can actually do better.
Is there a better way?
Yeah, so in addition to all the tooling, the utilities that we saw in Kubernetes that you can use for debugging, sometimes you just have to take it a step further, right? You can, of course, push out new code exactly the way that Matt talked about, but I actually have a debugger attached to my application right now. And this is the same debugger agent that's running the Google production environment, right? So this agent, you can actually run your own application as well. It doesn't matter where your application is running. It doesn't have to run on Google Cloud. Once you attach the agent, this is what you can do, actually. Let me get rid of some of these things.
Right.
Yeah, what?
How does the debugger know that it's looking at the right version of the code?
Oh, that's a
'cause
very
I've
good
got
question.
several different versions that have been deployed over time.
Yeah, so in my application, I actually added a git.properties file. This is using the git commit plugin for Maven and generates the git properties automatically. And what I will do is to put in the revision into this property file, and we can actually pick up the right revision. So you're always looking at the right version of the code. You can also do this directly to the IDE as well. But this is what we can actually do. If we want to add new log messages, we can just go to the code, which is on GitHub right now. And let me zoom in a little bit. I'm going to add what we call a log point. So we can just say, what do we want this? Let's put it here. So I'm going to say, number one, is how we debug everything, right? I'm here, right? And and you do like number two.
Done.
I'm here. Yeah, we're almost done. We're almost done. So maybe number three done, right? Yeah. But we can even print out potentially the variable. So we can say something like the city is, and we can give it the variable city. We can also add in what do you call the expression, so you can limit this to certain requests as well. As soon as we've done that,
Yes.
we got 10 instances running.
Yeah.
This is applied to all of the 10 instances.
Already.
Already. Yeah.
So let's hit it. Let's
Yeah.
generate that error.
So if I go here, if I hit this arrow, right? If today is my day, hopefully continuous and let's see logging. So we can go to logging, right? We're gonna go back to the logging console because we don't know which instance I actually went through. And if I went down here, I should be able to see. There we go. Log
Okay.
point 1, I'm
here.
here. Yeah, not bad. And log point 2, the city is now found. Well,
The city is not found.
so the city was not entered, I suppose.
So why isn't the city entered? I mean, of course the user is always going to enter a value for the city, right? Because they need to make a storm somewhere.
Well, it's a user error.
I think it's user error.
It's application.
It's user error.
Yeah, it's not
the
application.
application.
Yeah.
It's the user.
So we don't have to fix anything.
So who is running this demo?
Shoot. So what are you
you broke our
saying?
demo, man.
What are you saying is my error?
Yeah, it's your
I
error.
forgot to put in the city.
Yeah.
I guess I did. I guess I
Okay.
did. Yeah. Shoot.
Okay, so actually,
So
you
not solve the
actually
mystery.
could have tracked it down. That was pretty
Not
good.
solve the mystery. Yeah.
But I have one more complaint.
Yeah.
I still find that sort of logging, that way of adding log entries is kind of an annoying way to troubleshoot my code, right?
Right.
Even if this was pretty cool.
Yeah, it's
But,
pretty cool.
But then put this in, wait for someone to hit it, go to
Yeah.
the logs. I love just debugging. I just want to debug things. Can I just,
You mean like from an IDE?
yeah, I just want to, in my IDE, just say like, okay, set a breakpoint, step through it all. Can't we do that with these requests that come in? production?
No. Well, if you use a real debugger here, like the Java debugger,
Yeah.
the user will be paused forever until you step
Well,
through
then
all
I'll
the
just click
code.
next. I'll just be waiting there to click next.
Yeah, but we're gonna be sitting there and clicking next all day.
It's job security. We'll have a job for 5 years as long as Google Wind is alive.
Whenever the requests are responding, they're just say, hey, Matt, can you fix that?
No,
You'd be like, step over everything.
Yeah.
Okay, yeah.
Okay, no, but I mean, for me as a developer, this is like was the most effective way to troubleshoot something fast, right? So how can we do that?
Yeah, so actually, with the debugger agent, the same agent that you attached, you can actually install a plugin into IntelliJ, and you can actually use the debugger directly here as well. I do need to find out. There we go. I can say attach to a Stackdriver debugger. I haven't done this yet, so wish me luck. This is my first time doing this, right? So I should be able to scroll down and find my awesome demo here, right? So debugger, right? And I can just click on OK, and there's my debugging agent. And hopefully, crossing my fingers, I can go in here and I can say debug, okay? And it's going to find me the application I want to debug. I want to debug the UI. It's going to automatically switch it to the right revision of the code. There you go. And now I can actually add these breakpoints. These are what we call snapshots.
Okay, Bjorn, hit it.
Yeah.
Hit the page.
Is somebody hit the page, right? Or I'll hit it. So for example, if I go back here and do a refresh, there you go. Did you see it? So the debugger changed, and there's my code stack. And not only that, I can actually drill into here. I can also see the current state as well. And to make sure that we know and understand what is happening, I'm going to attach another debugging agent here. And if I said fresh, I capture the new snapshot. And if I go back, I can clearly see that CT is in fact empty.
So Bjorn, can you submit one to him? We'll see if we can catch your thing. And just to clarify, I think Ray said it, but we're capturing a snapshot. So we're not blocking production.
Right, exactly, yeah. So, well, that solves the mystery of why this demo failed. Well, thank you for...
Good job.
Yeah, thanks. I guess I broke it. Yeah, yeah, well, very cool.
So hopefully you guys have learned a little bit about the troubleshooting paths in Kubernetes, a couple best practices for it. Do you want to do a recap?
Yeah. Let me do that very quickly. Just so you know, right, I think everybody knows, right, that deploying something into production is just not enough. You need all the tools available to you to be able to see what's happening inside. When something does happen and something unexpected like this one, like who would thought like the empty string would have caused such a big issue, then you need all the tools to help you to debug it. And we saw the Kubernetes utilities. You can get into the logs, you can get into the bash, you can also aggregate all the logs together. So all the tools, and if you want to get a step level into this, right, you should have some kind of distributed tracing or additional tool that allows you to see the real-time information on what's happening in the cluster. And we can see in this case, trace really help us to debug this and figure out what happened. And log messages, of course, and if you can, you run a little debugger that does not stop the world. Right? And so if you want to try some of the tooling that I show for Stackdriver, you can. You can just go to the Stackdriver page and you can try some of these things. Otherwise, you can use the out-of-the-box Kubernetes utilities and also some of the open source toolings as well. So with that being said, I think our time is up. Is that right?
Yes.
Okay. So thank you very much for your time, and thanks for being here.
Woo.
You can find all the source code on GitHub. This is real, and you can find more information there. Any questions? Do we have time for questions?
Do we have time for questions? What time is it? How are we?
10 minutes.
Oh,
okay.
We moved fast.
Yeah. Oh, we still have 10 minutes.
10 minutes.
Oh, I thought this is until 5:40 or 5:30. Well, I guess we have questions then. Yeah. This presentation will be on GitHub, especially this special version. Yeah, there are other versions of it that uses a different app, but this special version that only you got to see it is actually here. Yeah, because we got the awesome Matt here. So yeah. Question in the back? Yeah. Changing the log level without killing the pod. I do see this quite a bit. The question is, can you actually do that dynamically? If you can, maybe. But you gotta be careful of what log level you put in there, right? Because the more you log, the slower, the more production users will feel it. So, I mean, would you want to drop it down to trace? That means everybody? Probably not, right? So you gotta be careful. My preference about Kubernetes is always change configuration with the configuration maps, and you do a rollout for any configuration changes that you make. Because that small change of the log, if somebody actually put tracing there, for every class, you're going to be in even bigger trouble if it's applied to everybody, right? So I don't want to do it. If I do it, I'm going to do a slow rollout and see what happens. Yeah. Yeah. Any other questions? If not, there are a few things that I did skip. I'll just show you what that is, because I want to make sure we have all the times. So one thing that I didn't show is that if you do capture the data in trace here, right? One of the things that we can do is, because we know all the latency of every code that you make, or whatever code that you wanted to be sampled, we can actually build a latency distribution graph, right?
This is great. So when my product manager is yelling at me about not meeting the SLA,
yeah,
I have hard data about whether I am or not.
Exactly.
Which services are causing trouble.
Right. Yeah. But more than that, you can also pinpoint which service is having trouble, right? So for example, if you go to this trace, you can see that maybe that service is particularly slow. You can definitely see it. But we can do even more. We can actually generate automated reports to detect regression. So because we have the data, we can compare this week versus the previous week. And if we detect a significant regression, we can send this report to you automatically.
We can also generate reports comparing different versions.
That's right.
The same tool.
Yep.
So, okay, the version that we rolled out yesterday and the version that's been running for a month, the last month, what's the differences between those?
Exactly. Yeah. And even more than that, because we did output all the error messages to STD out, we also can capture the exceptions automatically as well. And when we do capture the exceptions, this is called error reporting. We can automatically surface you the most frequently occurring exception. If something brand new, I actually got an email about this. There was another exception that popped up. I got an email for it. So I can see that very clearly that we got this HTTP client error exceptions. I can click into this thing, and I should be able to see all the logs as well. I click into the thing, I can see all the logs. In addition to that, for every trace that you make, if you actually linked up all the things properly, let me just go to trace. If I go to one of these trace points, if you linked up everything properly, what that's going to do is give you a little button here that says logs. So when you click on it, it's actually going to go back to the logging console and do a search correlated with the trace ID that you used, right? So you can really have end-to-end visibility from the application debugging perspective. This is really, really awesome. Okay? So, any other questions? Yeah.
What metric do you have to perform in order to get leaf score set up?
Oh, that was pretty cool, right? Yeah. They actually give you live traffic lines, and that's one of my favorite things. So if I go back to 40, did I still have it running? I do. Yeah. And if there's a new connection between these two services, you actually show up. Weave scope is really, really easy to install. Let me just say weave.com. Let me see here. Sorry, not that one.
Probably not.
No, not that one either. I'm sorry. Weave work. Sorry. I knew that. Oh, come on, Weave work. Come on. Weave scope. I just do a search. Google will always.
Google will help.
Yeah. Not those Weave scope. Just
This is a good one.
Yeah, this one's cool. And you click on install, and this can install on any Kubernetes cluster. It literally takes one line. If you're using Helm, you'll just use Helm like install. If you want to use Kubernetes apply, you just give it a URL. Let me see if I can see the apply here. There we go. So you can do kubectl apply -f. You give it the scope YAML. And there's a standalone version, and they also have a service, of course. Yeah, so you can do that instead. Okay? Yeah, it's pretty easy to do. Just like that. Just like that, you get Weave scope installed. Yeah. For the debugging agent, you add a little debugging agent to the Java application startup. Yeah, question in the back? Beam applications. You know what? It should be. Yeah, it should actually be. Yeah. In fact, if you're using Apache Beam, you probably know this other wrapper called Seal. So Beam is the data, ETL pipeline language, right, with the Java as the core language, and then you can write this long pipeline. In Java, you have to deal with generics. You got to deal with types. It's for the first time I'm going to say it, it is a verbose API, but it's very, very powerful. If you want something simpler to use, you can use a Scala wrapper built by our friends at Spotify. And that's Scala, and the debugger also works with Scala, but it's unsupported, but it works. Partially because there are people using Scala to write the Apache Beam stuff. Yeah. So you should give it a try. Again, don't quote me on it, but it is not supported, just saying, for Scala. All right? Okay. Good. Any other questions? No? We're all good? Well, thank you so much for your time, for sticking around, and thank you for being here.
Thank you, everyone.